Today on How It's Made. Aluminum foil. Snowboards. Contact lenses. And bread. Aluminum foil has a multitude of uses, from heating something up in the oven to keeping something cold in the fridge. But have you ever wondered how a huge block of solid aluminum gets transformed into a paper-thin sheet of foil? The manufacture of aluminum foil requires the repeated thinning out of a large block of aluminum. We begin by melting ingots of 100% pure aluminum in a natural gas furnace. These ingots, called pigs, are essential in alloys with zinc, titanium, and silica. It takes 3 to 8 hours to melt 30 tons of aluminum in this remelting furnace, which operates at 1,380 degrees Fahrenheit. The fusion temperature of aluminum is 1,220 degrees Fahrenheit. A portion of aluminum is poured into this small mold to make a sample. Solidifying in just seconds, the sample allows for testing to verify the contents of the prepared alloy. This trough is used to transfer the aluminum from the remelting furnace to the tapping well. Molten aluminum runs in a movable trough located above the tapping well. At this stage, impurities are filtered out in special receptacles. The molds are cooled with water to accelerate the solidification of the molten aluminum. Ingots are unmolded and are ready for milling. Each ingot is massive, measuring 14 feet in length, 5 feet in width, and 18 inches thick. It weighs a whopping 8 tons, so it has to be handled by overhead cranes and placed on special plates. This crust-removing machine removes 1/10 of an inch of the ingot's thickness. Impurities are eliminated to achieve a perfectly smooth finish. All traces of the liquid used to cool the decrusting knives have to be eliminated. The many steps in the thinning of the ingot begin. First, the aluminum block is crushed by the hot mill rollers. Temperatures in the rollers are between 850 and 1,000 degrees Fahrenheit. Pressure on the ingot is continually verified by a technician. If the pressure is too great, the technician will lower it. The heat is so high that the ingot risks sticking to the mill's roller. To prevent this, everything is cooled with a liquid that's 95% water and 5% oil. Starting from a thickness of 18 inches, the ingot becomes increasingly thinner with each pass-through. Depending on requirements, the ingot will go through the machine between 12 and 16 times. The ingot now measures about 3 inches in thickness. It has to get down to just 2/10 of an inch. At this stage, the ingot is about 2 inches thick and measures almost 30 feet in length. This conveyor transports the plate during its milling stages. The ingot has become a sheet 2/10 of an inch thick. It is sufficiently thin to proceed to spooling, where it spools onto itself before being sent to the cold rolling mill. There, its thickness will be reduced still further. The aluminum sheet has become very thin now and risks being broken by the tension needed for cold rolling. So the sheet is doubled to avoid this breakage. One final reduction in the mill, and the sheet will have the thickness required by the customer. A liquid coolant is used to prevent the foil from sticking to the rollers. Since the edges of the foil sheet are lightly damaged and crinkled, a knife removes a strip 4/10 of an inch wide. Finally, the roll is cut to the desired width, and one huge ingot has produced nearly 8 miles of foil.